So for number 4, we're being asked to find the first three terms in the expansion of 2 minus 3 over 2x to the power 5 in ascending powers of x, right? And so we'll start with 5 choose 0, then 5 choose 1, then lastly 5 choose 2 to get our first three terms of that expansion. So say 5 choose 0, then we say minus 3 over 2x to the power 0, then this 2 to the power 5 minus 0, that's 5, plus our 5 choose 1 times minus 3 over 2x now to the power 1 times 2 to the power 5 minus 1, that's 4. And for the third term, we'll say 5 choose 2. Then we multiply that by minus 3 over 2x to the power 2. Then we multiply by 2 to the power 5 minus 2, which is 3, right? And punching these in our calculator, 5 to 0, that's 1. Then this whole thing to the power of 0 is 1. So it's only 2 to the power 5, which is 32, right? Then for the second one, it's 5 choose 1 being multiplied by minus 3 over 2 and 2 to the power 4. And that should give us minus 120x, right? Then for the third term, we are saying 5 choose 2, then minus 3 over 2 is being squared, then we're multiplying that by 8, so we get 180x squared, right? And if we look at powers of x, we have x to the power 0 for this 32, then x to the power 1, then x to the power 2. So those are the first three terms in the expansion of that in ascending powers of x. Then we get our 3 marks right here for part A, right? And so moving on to the second part, which says use your answer to part A with a suitable value of x to find an approximation for 1.985. We are required to use our answer from the previous part with the suitable value of x, right? And we know that for the first part we expanded 2 minus 3 over 2x to the power 5. So we're expanding 2 minus 3 over 2x to the power 5, right? And we want to use that to approximate 1.985 to the power 5. So for us to find the suitable value of x, we are going to compare these powers, and you can see that we have 5 on 2 minus 3 over 2x and 5 on 1.985, right? So that means we can equate these two since the powers are the same. So we're going to say 2 minus 3 over 2x is equals to 1.985, so that we find the x value there. So it will be 2 minus 1.985 is equals to 3 over 2x, right? So 2 minus 1.985, right? That's 3 over 200 is equals to 3 over 2x, right? So I'm going to multiply both sides by 2, right, to get 3 over 100 is equals to 3x. Then I'm going to divide both sides by 3 to get x equals to 0.01, right? Get x equals to 0.01. So this is the suitable value of x that the question is talking about. So with this value of x now, we are going to use our answer from part A, which is this 32 minus 120x plus 180x squared, substituting this value of x into that. So we're going to write 32 minus 120x, we write 0.01, then plus 180 x squared, that's 0.01 squared, right? Punching that in our calculators, we get minus 120.01 plus 180 times 0.01 squared. We get approximation is 30.818, right? And that would be our answer right there. So if we were to compare this with the actual value of just saying 1.985 to the power 5, 1.985 to the power 5, it's 3.8178. So we see that our approximation is accurate, right? So this is the answer for the second part, right?